It's December, and I don't know about you, but I'm excited for the holiday season. Luckily, our project today is just in time. Today, we'll be exploring Pascal's Triangle. For those of you that have never heard of this before, let's learn it. What is Pascal's Triangle? Well, the answer is essentially in its name. It is a triangle made from numbers. You start off with 1 like this, and continue by adding 1 to the next row, like this. However, when you have to put a number in the middle of the triangle, like in between 1 and 1 in the third row, you add the numbers in the row before. So the third row becomes 1, 2, 1. That might still be confusing, but don't worry, we'll keep working on it. For the fourth row, we add 1 to the left side, and then, since 1 plus 2 is 3, we write 3, and once again, 3, and finally we end with another 1. How about you try the next 2 rows? Take your time and unpause the video when you're finished working on it. Now that you've taken a stab at it, let's check our answers. Is this what you got? We'll add the numbers as we continue downwards, and as a result, our numbers get bigger and bigger. Another thing you should know about the Pascal's Triangle is that it is never ending, meaning that it continues on forever. It also, as you might have seen already, creates a triangular shape, hence the name. Now to our project. Today we'll be making a Christmas tree out of Pascal's Triangle. For this, you're going to need a piece of graphing paper, a pen or pencil, a ruler, and some markers to color in your tree. First things first, take your paper and find a square near the center to start your Pascal's Triangle. You should start off with 1 because that is the first row of the triangle. After that, skip a row and do the next 2 numbers of the Pascal's Triangle, 1, 1. Skip another row and write the next numbers, and so on. If your tree is like mine, you'll probably want to stop around the 11th row of the triangle so you have enough space to draw the trunk and some presents if you'd like. After you're done, take your ruler and draw a line connecting the tip of the first row to the bottom row, like this. Do the same thing for the other side and also use your ruler to draw a line along the bottom row. Now you have the shape for a Christmas tree. It's time to get creative. Using the colors you have, decorate your tree however you'd like. Also, don't be afraid to use colored pencils, markers, etc. Make sure to add the trunk at the bottom of the tree along with some presents. After you're done, it should look something like this. So festive! It is a perfect way to begin the holiday season. And of course, do not forget the star right on top. But what else is the Pascal's Triangle used for? Before we answer that, let's first look at some of the patterns in the triangle. The Pascal's Triangle is known for its many patterns, and math is the study of patterns, so it fits quite nicely. One pattern that you might have recognized already is that the numbers along the sides of the triangle are consecutive, meaning they're in counting order. And if you draw a line down the center of the triangle, the numbers are symmetrical. Whatever's on one side is also on the other. Another pattern is the number of numbers on each row. The first row has 1, the second row has 2, and so on. It's also in counting order. Now on your own, try to look for some more patterns. Trust me, there's a lot of them. Now let's go back to our original question. What else is the Pascal's Triangle used for? Well, it is used in many areas of math, but one of the most important is in algebra. Polynomials use the Pascal's Triangle. For example, when you multiply out x plus y to the power of 2, you get x squared plus 2xy plus y squared. Take a look at the coefficients, 1, 2, 1, just like the third row of the Pascal's Triangle. What about x plus y to the power of 3? Well, that equals x cubed plus 3x squared y plus 3x y squared plus y cubed. And the coefficients, they are the fourth row of the Pascal's triangle. Adding 1 to the degree of the expression gives you the number of the row that the coefficients are from in the Pascal's triangle. However, expressions such as 2x plus 3 to the power of 2 are a little more complicated. Because the x already has a coefficient in front of it, and the number being added isn't 1, or doesn't have a coefficient of 1, we can't just write the answer out using the Pascal's triangle directly. And that is when combinations come into play. But that's for another day. I hope you had fun making the Christmas tree with me using Pascal's triangle. Make sure to look for patterns in the triangle on your own because there are many that could be found. I hope you have an amazing holiday season and I'll see you next time. Bye!